Right, welcome back. So let's talk about Chapter 7. Chapter 7 is the very brief chapter, probably in our textbook. This is the shortest chapter we have. In this chapter, we'll talk about validation, especially input validation. Input validation means that when we are expecting some kind of input from the user, some kind of interaction, we just need to make sure the user provides us the correct type of data we are expecting. Remember, the users are not technically savvy all the time. So when we are expecting certain kind of value, for example, for age, for date, for time, for social security number, for a credit card number, so we are expecting certain things in certain order. So those must be provided in the correct order. The range should be correct. All those things must be validated by the developer. So let's look at this chapter. In this chapter, we'll talk about garbage in and garbage out, and we call it GIGO or GIGO. Whatever, if the garbage comes in, you're going to get expected result will be garbage as well. So we need to ensure the input is validated correctly, and this is called defensive programming. And the programming is basically you are expecting unforeseen errors, or you're expecting errors by choice from the user. So you just want to make sure that how do we ensure that we are getting the correct ranges, correct kind of types of values on data type. All right, so if the program reads the bad data, if the user gives you the bad data as an input, and guess what? It's going to produce incorrect results. It's going to give you the report or your paycheck or your retail transaction. It's going to give you the incorrect value as well. Imagine you go to Walmart and you purchase one item, let's say loaf of bread. And then imagine if the clerk enters 1,000 items in 1,000 loaves of bread. In that case, it's gonna there should be a check, some kind of check, unless it literally happens somebody purchases 1,000 items at the same time. So those are some of the things programmers needs to be aware of. So we should be, and the program should be designed to accept only good data. Any bad data, and this is where your analysis comes, that particular industry's analysis, and they actually analyze and they say, okay, this is the only acceptable range. If somebody wants to do something out of the range, then probably they have to call the manager or they have to do something different. But here, as a developer, you need to anticipate some of the bad data, and that's why you want to correct the bad data. So the first thing is input validation. So we want to make sure that data is whatever comes in from the user must be validated. So all input should be inspected before we process anything. If it's invalid, it should be rejected. And we should ask the user the second or third or fourth time, or maybe up to 3 times. And after 3 times, we can simply display a message, sorry, you're having a trouble. Please come back, log back in later. So it should be rejected and the user should be prompted to enter the correct data. So imagine if you are expecting the date in numbers and the user gives you characters. So you can display some kind of message back to the user, please enter the date in this particular order, month, day, and a year. Remember, in many other countries, that's not how the date is entered. In some countries, the day, month, and year. In some countries, year, month, and date. And so it's very, so you just need to be aware of that this particular system is basically applicable in which country, which region, and what kind of data is anticipated. All right, so here we will look at this particular example, and this is just your pseudocode. So we are expecting some kind of hours and rate, and then hours times rate calculates the gross pay. We have seen this kind of program before as well. So what if somebody gives you 400 hours in a week? Now, this is invalid. Nobody can work 400 hours in a week. That is not somebody and made a mistake. Somebody entered an extra zero by mistake. So the rate is probably okay. So in this case, per week, this individual made $8,000, but because he or she worked 400 hours a week. So we should be validating that one, and that should be validated. That's what it's going to show you how to validate it. So input validation is commonly done with a loop that iterates as long as it provides or you receive the correct value. So you're going to loop through it. You're going to display some kind of message to the user. You're going to say, well, this value is not valid. This is the range. This is the correct value. Please provide me the correct value within that range. So how do you do that? Let me move on to the next screen. So here you can see we are getting some kind of score. And notice that under here, right under here, we are checking the range for that score. We are saying the range should be between 0, less than 0, it's not acceptable, or if it's greater than 100, it's not acceptable. If that's the case, if it's less than 0, somebody provides you a score -5, or somebody provides you a score, let's say 120. So it's going to display an error message, and it says the score cannot be less than 0 or greater than 100. Either way, greater than 100. And then display the correct score. This is the message back to the user. We are prompting the user and asking the correct score once again. So it's going to stay in this loop forever. It's going to stay in this loop for a long period of time, as long as the score provided by the user is invalid. So this is just one way you can look at it. This is called priming read, and this is the first input to be tested. So you're expecting a certain kind of range for the score. And this is applicable to the previous example as well. Let's say number of hours. You can say, well, number of hours cannot be less than 0, and number of hours cannot be, let's say, more than 100. Some people probably work more than maybe 100 hours in a week. But that is where industry or their threshold or their benchmarks come, and their decision comes as an industry that how many hours maximum are possible. So writing validation functions, it is for complex validation. For complex validation, it is recommended to write a function, just like what we did. We showed you right here. Actually, we did not. So we will actually write a function. We'll go to the next screen and write a function. So it is recommended to write a function because it is much cleaner, much easier to modify it. And that probably is a better way to do it, because you are validating something which is a separate task. It should not be mingled or mixed up with the regular flow of the code. So then it is recommended that you actually write a separate function for validation purposes. Now, some of the string validation inputs, a lot of these functions already exist. If they don't exist in the libraries, then you can create some of those. So some string must be validated, such as those programs that ask for specific string input like yes or y or no or n. So in that case, you can actually have some kind of validation for that particular value as well. Or programs that specify a string to be specific length, like a password. So for example, in your organization, the maximum password length could be 16 or whatever you decide, but it cannot be less than 8, for example. These days, many of the organizations, when you try to create a password less than 12 characters, it gives you a message. The password must be 12 characters or more. In the past, if you remember, it used to be 8 characters. And in some organizations, there's no limit. So then you decide as an organization what is the maximum password for that particular case. And if the password is less than that textual data, then it should display some kind of message. So input validation is called defensive programming, the practice of anticipating both obvious and unobvious error that can happen. And this is where the experience of the developer comes, the programmer. They anticipate certain things, that there's a chance the user might make those kind of mistakes. So you put that or embed that kind of validation into your code. Now remember, that validation probably might never be triggered, because if you're expecting certain type of data and the user is always providing the correct type of data, then that particular function for validation purposes might not be called. But you still need to place that code there just in case one or two individuals, they provide you the invalid data. So you are not reading the garbage and processing the garbage. So types of errors to consider: empty input. Imagine if the user accidentally hits enter key before entering any data. And imagine if your program accepts the data, accepts a space, or accepts the enter key, or accepts anything which is not really useful for us to process. Or user enters the wrong type of data. I gave you several examples that you're expecting a date or age in numbers, and the user basically types those things in text. So common errors to be aware of. State abbreviations, for example, in our country, there are two character strings. So for example, for state of California, CA, and you should be able to accept uppercase CA, lowercase ca, and even I would actually recommend even C upper and A lower, because some people actually have uppercase turned on by habit and they are a lowercase a. Or in that particular case, if you want to be on a safer side, you can use two upper or two lower, which we saw in the previous chapter. You can convert the strings into all lowercase or all uppercase for comparison and validation purposes. And the zip codes in our country, they have either 5 digits, or if you have the extended zip code with the 9 digits. So hourly wages and salary amounts should be numeric values and within certain ranges. Remember, we saw an example earlier. The hours should be within certain range, and you as an organization, you can decide, well, maximum hours in that particular organization per week cannot be more than 100, for example. And then if somebody provides you a bigger value or somebody provides you a negative value, that should be rejected. And same thing applies with wages as well. Dates should be checked. So many of these functions either pre-exist or you have to create some of these functions. Date should be in our country month, day, and year. 2 digits for the month, 2 digits for the date, 4 digits for the year. And you can actually, in many cases, when you are about to type the date in different apps or different kind of websites, you probably see a sample shown, kind of transparent sample. It shows you what is the format of the date they're expecting. So I know that most of us, we are not going to type the characters for the date, but you never know. Some people might type JULY, July, and then they might type, let's say, 10. Then they might put comma there. They might put the 4 digits for the year. You want to be careful that you're not expecting that kind of data. And you can display a message back to the user. You're expecting a date in 2 digits numbers, 2 digits for, 2 digits for the month, 2 digits for the day, and 4 digits for the year. And time also be checked, just like your date, and check for reasonableness for the numbers. Numbers should be reasonable. You're expecting numbers. You're not expecting some kind of textual data. So those are some of the things. So as I mentioned earlier, this chapter is a very brief chapter. So we'll look into some of the examples in Java, Python, and C#. Let's look at the first example here. So here we can see we are getting getting a local variable. This local variable is actually we are calling the function here. We are calling the function here show retail. Show retail function is being called, and that particular function will be shown in the next screen. So let's go to the next screen and show retail. You can see it's reading some kind of it's reading enter items wholesale value and picks up the wholesale value. The wholesale value is being validated. It's not less than 0. So whatever the item is, it's expecting some kind of a value for that item. Remember, you can purchase, let's say, milk, or you can purchase a shirt, whatever it is. So here its validation is happening. It's saying that the value of this wholesale item should not be less than 0. And if it's less than 0, it says cost cannot be negative. Please enter the correct wholesale value. Then it tries to pick up the value again. If the value is entered correctly, it will not enter the loop the second time. The value will be captured here, actually captured previously, but a value shows up here, and then you have a markup. So markup is a value which is 2.5 here. So that's your markup. That is probably the profit markup for that particular organization. And then it displays the retail value. The retail value, which is stored here, it will be displayed right there. So in this case, this validation function, which is right here, it is being called from the main function. This is your main function. So this show retail function basically calls that function. Then after this function has been called, then he said, do you want to continue, yes or no? So here you can see that user is being asked to provide some kind of input value. If the user provides either lowercase y for yes or uppercase Y for yes, because here we are displaying enter Y for yes. If the user provides either lowercase or uppercase, then it stays in that loop and it calls that function again. It stays in that loop, calls that function the second time, and it goes through the process again. If the user enters any other value, not necessarily N, it can enter P or Q, whatever it is, then it's going to exit that particular do while loop, and then it will continue to at the end of the program. All right, let's look at the same program in Python. So here we are calling the show retail. I'll come back to the while function in a bit. Show retail is displayed here. There is a show retail function. And as you can see, everything is indented. So here we are asking for the user to enter the value for the wholesale cost, and the value will be inputted as string. It is being converted into float or a real value. And then we, just like what we did earlier, so we are checking in a while loop, if the wholesale value is less than 0, display an error message, and expect the user to enter the correct value again. If the user enters the incorrect value the second time, it's going to do the same thing and the same thing. So you can stay in that loop until the user provides you the correct value. And then you can do the same thing here. You can multiply the markup times wholesale, and display the retail in this particular case. So if I go back to the previous screen, so here show retail is called the first time. And then here you can see while another yes or no. So initially this another value variable, which is a character variable, is set up as y, lowercase y. So in the first time, in the first cycle, it was y. And because there is an or in between, it means it could be a lowercase y or uppercase y. It stays in that loop as long as the value of that particular one says provided by the user is lowercase or uppercase y. And then it's going to continue to call that function. And then here, do you want another item? Yes or no? Because previously the value was not, this question was not asked because the value was previously set as a literal value. Then if the user says, yes, I want to continue, then it's going to stay in that particular loop. All right, let's look at the same example in C++. So C++ calls the same function again. I'll come back to the do while function in a bit, but you can see do show retail function. This is very similar to Java, and here's my show retail function right there. In my show retail function, declared a couple of variables, wholesale and retail. Markup is also declared as a constant. How do I know it's a constant? That's what it says, constant. And then we are expecting the user to enter that value, and we say enter an item's wholesale cost. And let's assume the user gives you -5. So -5 cannot be a valid value because we are checking right here, wholesale is less than 0, means it's negative value. Then we can say cost cannot be negative, enter the correct value, and we grab the correct value from the user. If the user refuses to provide the correct value, continues to provide the negative value, it's going to stay in that loop. Now, it might be a good idea after 3 or 4 or 5 tries, you can exit the program. You can simply say, well, sorry, you're having trouble with this program. And you can do that by putting the second condition in while loop. You can actually have some kind of counter. If the counter reaches, let's say, a certain number of times, 3 times or 5 times, you can exit that loop, and you do not have to calculate the retail value. Otherwise, if the correct value is provided, you can actually take the correct value from the user, multiply it with 2.5 right there, and then display the results. So if you go back to the previous screen, because this function is part of do while loop begins right here. If you remember, we did that one in chapter number 4 when we talked about different types of loops, and I did mention that this is one of the loops I don't like, but it has its own place. So because in this particular case, you enter the loop the first time without any kind of a pre-test. So you enter it, and then if after this function has run successfully, then you say, do you want to continue or not? If the user gives you y for yes, then it could be lowercase y or uppercase y, just what we saw in our Java program. Then you stay in this loop and call this function the second time or third time. If the user provides you any other character other than y, then you exit that loop. All right. So we are done with this chapter. This chapter was really a brief chapter, as I promised. This is a much, much, much easier chapter. And I hope to see you in the next exercise, next chapter, chapter number 8. And let me stop my